talking about some work that CU is doing on looking for the next extrasolar planets. And our motivation for this work is kind of an age-old question of, are we alone in the universe? Is there life out there, or is life something that's unique to Earth itself? And with the recent discovery of thousands of exoplanets in the last few decades, we were finally able to start addressing those questions. However, one major problem with finding these exoplanets is that they're extremely faint. They're about 10 billion times fainter than their host stars. So when you point your telescope at the nearest star, you see this first panel on the left and just the glare of the star. You're completely swamping out the signal of the exoplanet. And people liken this to trying to see a firefly next to a lighthouse. However, in the last decade, a professor here at CU, Dr. Webb Cash, invented what's known as a starshade, which is that flower-shaped, silly-looking thing over on the right. And a starshade is an external occulter, and it works in the same way that you would put your hand in front of your eye to shield yourself from the sun. So you fly your starshade in front of a telescope, and it blocks out the light from the star and allows you to see fainter objects such as exoplanets nearby. And the shape of the petals on the starshade are mathematically proven to maximally suppress the light and allow you to see extremely faint objects, take spectra of these objects to determine its composition, and search for biosignatures of life on these planets. And to ensure starshade selections in a future mission, we need to demonstrate them with observations. So with the help of this research grant, I propose to do the first ever astronomical observations with starshades from a hilltop, from the mountaintop. So our experiment for what we will build with this, it can be seen in this cartoon on the right. We have a telescope at the base of a mountain, and about a few kilometers away on top of the mountain, we have a half-meter starshade. The starshade is on a movable track, so that as the star moves across the sky, we can continuously follow with the starshade and increase our exposure time, allowing us to see very faint objects. One of our first targets we will go after is a ring of dust left over from planet formation around a nearby star called Fomalhaut, seen in this image. This image was taken by the Hubble Space Telescope with about an hour of exposing time. However, starshades work so well that we're able to suppress the light of the star orders of magnitude better than what Hubble can do. So we expect to see something. We won't get the same resolution as Hubble can, but we'll be able to detect a faint object like this in a matter of minutes, and even see fainter objects that Hubble cannot see. So it's kind of we have this unique opportunity to, with a really relatively inexpensive project, especially as space missions go, or as astronomy goes, to detect new objects and start to do new science on planetary formation. And additionally, we will demonstrate how well starshades actually work. It's kind of a critical time right now for starshades and exoplanet science. As we approach the mid-decade, NASA is starting to make decisions on what the next major mission will be. And right now, starshades are an underdog to more highly funded missions and technologies. However, I believe that we can really change the game for starshades with this project, this demonstration. We can show how well starshades work, getting images comparable to Hubble images with a few $1,000 setup, and we'll make sure that NASA sees that we are the future of exoplanet science and that they must invest in this technology for future missions. And they'll put CU in a very good position to play a leading role in the next billion-dollar mission in which we will search for the next habitable Earth, next Earth-like planet that can sustain life, and possibly even search for life itself. So, thank you.
Question for Anthony. Yeah.
Hubble is above the atmosphere. If you're looking through the Earth's atmosphere, how much spectral data on a planet can you get?
Yeah, so that's a good point, is that we will be looking through the atmosphere. So this will be a much grainier picture than what Hubble can see. It'll be smeared out. We won't get quite the detail that Hubble can because we have to look through the atmosphere. However, in terms of detecting that it's there and seeing other debris that can't be seen by Hubble will be able to surpass Hubble in that aspect.